today I'll be showing how to prepare your DNA library for sequencing using the Oxford nanopore. So we'll be making use of different kits because for the protocol we use different kits at each stage. So we'll be using the Rapidout DNA to digest our DNA, our DNA, because we need to synthesize the complementary DNA from our nucleic acid. Then we'll also be making use of the amplified DNA polymerase for whole genome amplification, and also the Repligy kit. So first we'll start by using the Rapid DNA out kit. So the first thing I'm going to do is to wipe the surface of the bench where I'll be working on to avoid contamination. And to do this, I'll be using 17% ethanol. So I will gently wipe the surface of my workspace with ethanol. Also, due to the fact that I'll be working with high fidelity polymerases, I'll be disinfecting everything that I'm gonna use with 70% ethanol, not just my working space. So I'll clean the pipettes, the rack, and the surface of my pipettes, my pipette tip holders. I'm gonna disinfect everything with ethanol to avoid contamination with my sample or my consumables. To disinfect my pipettes, I'm going to first pour a little bit of the ethanol on my sheets, then wipe down the pipettes. So in a normal condition, this process will be performed in the PCR hood cabinet, but since this protocol is designed to be used on the field, this is a very important step to disinfect everything we'll be using. Here I also have my calculation for every consumable I'm going to use. So I have 10 samples and a non-template control, so making it a total of 11 samples. So you could see here I've multiplied everything by 11.5. It's always better to go a microliter higher, but in my case I'm going only 0.5 microliter higher because I want to save the consumables. So first I'm going to start by making a master mix, because if you can see, these are quite small volumes, 1 microliter and 0.5. So I will first make a master mix this will help me have control of my consumables and the whole procedure. To start by labeling my tubes. So since the first thing I'll be doing is to use the Rapidout DNA kit, which is a kit that helps digest DNA. So I'm going to label my first mix RA master mix M mix. So based on my calculations, it says I need to take 11.5 microliter of DNS buffer. So with my P20, I'm going to take 11.5 microliter. So also, while opening the tube, you should be careful as to not touch the rims of the tube, because for this process every step or everything is critical, just to avoid contamination. So if I want to open this tube, I hold the tip of the 1.5 ml tube, just to avoid touching the rims of the tube. So next I'm going to add 5.8 microliter of DNA on. So I'm going to add 5.8. So next is I'm going to make aliquots of my sample. I have 10 samples and a non-template control, making it a total of 11 samples. So I'm going to use 200 microliter PCR tube. So care should be taken as to not touch the rims as well. So now I have 11 PCR tubes. Next thing I'm going to do is to number them according to my samples. So this is sample 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is my control. So in each tube, I'm going to add 8.5 microliter of my sample. So here I have my samples here numbered 1 to 10. So I'm going to take 8.5 microliter from each sample, and I'm going to add them to the designated tube. So to my template control, non-template control, I'm going to add same 8.5 microliter of mucus-free water. So when this is done, next thing I'm going to do is add 1.5 microliter of my master mix to each tube. So to each tube, I'll add 1.5 microliter of my master mix. And to do that, first thing I'm going to do is I'm going to flick the tube for homogeneity. I'm going to, and proper mixing, I'm going to flick the tube. Then I'm going to centrifuge. So I'm going to take 1.5 microliter from this and add to each sample. So I mix by pipetting up and down when I add to each sample 3 times. By pipetting up and down. So when you're done adding to every tube, next thing you're going to do is you're going to set up the PCR reaction. You're going to incubate for 30 minutes at 37 degrees Celsius. But always pin down your tube, your PCR tube. Always centrifuge your PCR tube before you place them into the thermocyclone. So and make sure they are tightly sealed. So for 37, for 30 minutes. So I'm going to start. 10 microliter starts. So when after 30 minutes, I'm going to stop the reaction. So now 30 minutes is done. I'm going to stop the reaction and take the tubes. So when I do, the first thing I'm going to do is pin it down. So after that, I'm going to add 1 microliter of my DNA removal reagent. So to add this to every unit of DNA added to your reaction mix, you're gonna add 2 times the unit. So in this reaction, I added 0.5. It's not up to, I added less than a unit, so that's 0.5 microliter of DNAs. So meaning I'm going to use 1 microliter of DNAs for each sample. So I'm going to add 1 microliter of DNA removal reagent for each sample. And prior to the use of DNA removal agents, you have to vortex. I normally flick. You have to vortex, then centrifuge a little bit, just a few seconds. And I'm going to add 1 microliter of this to each tube. When I'm done adding 1 microliter of DNA removal reagent to each tube, next thing I'm going to do is to incubate at room temperature for 2 minutes. So I will let it at room temperature for 2 minutes. So after 2 minutes, I'm going to resuspend again by pipetting 2 to 3 times. So I'm going to do it to each sample. Always remember to avoid splashing when you're doing this, and avoid speaking or talking directly into your PCR tubes. So after this, the next thing I'm going to do is I'm going to put this in a centrifuge. So I'm going to centrifuge this centrifuge machine here. So as you can see, this machine is designed for 1.5 to 2 mil Eppendorf tube, and what I have here is 200 microliter PCR tube. So to use this machine and also to be able to centrifuge what I have in these tubes, I'm going to use either 1.5 mil or 2 mil Eppendorf tubes. So what I'm going to do is I'm going to break these tubes into single parts. And always remember to balance your tubes in the machine, so as to avoid the machine breaking down. then I will tightly seal. So I'm going to centrifuge this for a minute at 115 RCF. So I'm going to click on start. So when it's done, I'm going to gently take off the tubes without disturbing the pellets. So as you can see here, there is a pellet by the side, a white pellet at the side of the tube. So I'm going to be careful as not to disturb my pellets. Next thing I'm going to do is to take out my nucleic acid, which is preferably RNA, without disturbing the pellets, the white pellets. So I'm going to label my tubes, my new tubes. I'm going to label them. So when I'm done, I'm going to take 10 microliter of my sample of my RNA without disturbing the pellets. So I'm going to be careful and gentle as much as possible. So I'm going to place the pipette by the side of the 200 microliter PCR tube and take my RNA without disturbing the pellets. So place by the side. You can see there is a pellet on the other side of the tube. Then I will gently take my RNA without disturbing the pellets. So next thing I'm going to do after transferring my RNA sample to a new tube, I'm going to make a master mix because I'm going to use the RevertAid to synthesize a complementary DNA from this RNA. So I'm going to make a master mix of my primers. The primers I'm going to use, the exo-resistant random primer and oligo-DT. So if you see here, I'm working with small volumes as well. So I'm going to make a master mix for this reaction. So after the master mix, I'm going to take 2 microliter of this master mix and add to each tube. So first I'll label my master mix tube. Then I'm going to add 11.5 microliter of exo-resistant random primer. This is my exo-resistant random primer. I'm going to add 11.5. And 11.5 microliter of my exo-resistant oligo-DT primer. I'm going to mix by pipetting up and down 2 to 3 times. So when I'm done, I'm going to take 2 microliter of my primer mix, and I'm going to add it to each RNA sample, to each tube containing my RNA sample. Always remember to mix by pipetting 2 to 3 times up and down. So when you are done with the addition of the primers, next thing is to centrifuge. So after that, I'm going to set up a PCR reaction. So I'm going to set up a PCR reaction and heat the reaction mix at 65 degrees Celsius at 65 degrees Celsius for 5 minutes. So after 5 minutes, after 5 minutes, I'm going to take up the PCR tubes and centrifuge again. So next thing I'm going to do is I'm going to make another master mix containing my reaction buffer and other consumables like polymerase and RevertAid polymerase. So in a new Rapidout tube, 1.5 ml Rapidout tube, I'm going to make another master mix containing my RevertAid consumables. So I'm going to add, in the new tube, I'm going to add 46 microliter of my buffer, 11.5 microliter of my Ribolog RNase inhibitor, 23 microliter of DNTP mix, and 11.5 microliter of my RevertAid polymerase. So using the P100, I'm going to add 46 microliter of my reaction buffer. So after that, I'm going to add 11.5 microliter of my RNase inhibitor. Next, I'm going to add 23 microliter of my DNTP mix. So I'm going to use the P100. Next, I'm going to add 11.5 microliter of my RevertAid polymerase. So I'm going to mix by flicking the tube and centrifuge. So here my master mix is ready. So here I need to have a total volume of 20 microliter in my reaction in different tubes for each sample. So but right now I only have 12 microliter in each tube, meaning I have to take 8 microliter of my master mix and add to each designated tube accordingly. So using the P20, I'm going to add 8 microliter of my master mix solution, which contains my RevertAid polymerase. So I'm going to add it to my tube containing my sample and primers. So I'm going to mix by pipetting up and down 2 to 3 times. So when I'm done, I'm going to centrifuge one more time. So next thing, I'm going to set up the final reaction for cDNA synthesis. Cycling protocol for the cDNA synthesis. So it starts with 25 degrees Celsius at 5 minutes. So the cycling steps takes like an hour and 10 minutes. So after an hour and 10 minutes, you can take off your PCR tubes, either store them in -80 for if you want to use it tomorrow, or if you want to use it that same day, you can use it immediately for subsequent run, like whole genome amplification using the Amplify polymerase.